Hi guys, I hope everybody is ready and I think we can start. I hope everybody had a great conference so far. I really enjoyed NEC Oslo. It's a great way how they set up these online conferences here and also a very awesome set of speakers. So I'm Michael Staib. I'm a Microsoft MVP and I'm one of the authors of the Hot Chocolate GraphQL library for .NET. Today I want to talk to you about building real-time applications with GraphQL and Blazor. And if you think about it, with Blazor for WebAssembly, Microsoft for the first time in years gives us a viable option to build rich SPA applications that run natively in the browser. But we are going to take Blazor to the next level today by getting rid of the friction that you have with traditional data fetching technologies like REST or gRPC, and putting the front-end developer into the driver's seat. I know a lot of .NET folks still doesn't know what GraphQL is or even has the wrong idea about GraphQL. GraphQL is commonly mistaken for a graph database query language, but it actually has nothing to do with graph databases or even with databases. GraphQL is a query language for your API and a runtime to execute those queries. So let's dive in and have a look and explore in 5 minutes what GraphQL is and then head into our actual talk. So GraphQL is this thing where the consumer of the API or the front-end developer defines what he or she wants. Oh, sorry, that is home office. Lily, can you go out and close the door? Sorry, guys, my daughter sometimes just runs in. Okay, so GraphQL is this thing where the front-end developer or the consumer of the API defines what he or she wants. So this is done by writing up a GraphQL query. So the GraphQL query that you see here is basically fetching the current user and from the current user just the name. And if we send that to our server, we basically get our request filled up with data. It's not exactly like that, but it's a good mental picture to think about that. So we're sending in a request graph and the GraphQL server fills up that graph with data. But it's not only about flat data or simple requests like that. We could even decide to change our request. So we as the consumer could change our request without changing the server. And for instance, asking for the profile picture. And we don't only want the flat profile picture, we also want some metadata about the profile picture, like the width and the heights of that picture. And if we send that into our server, we get back a tree of data. So GraphQL is not only about flat data structures, it's also about getting trees of data. And if you think about this, it really is a more human way to explore data because you can drill into data. And with that, GraphQL actually gets rid of common problems like the N+1 problem on the client side. Because if I drill into multiple objects, like for instance, I want to fetch the current user that is logged into our service, and I want to have from that current user that is logged into our service the name and the date, time when he or she was last seen. But I also want to drill into that object and get the friends of that currently logged in user and the name and last seen timestamp of these users too. For instance, this might be useful to build up a list of online statuses of my friends on a service. And when I send that into the server is able to then just fetch these data in one go. And if we think about traditional APIs, and even Facebook had that problem back when they invented GraphQL, is that with REST, the requests are basically defined or designed ahead of time, and they don't represent all the use cases that there might be. So with REST, we would probably end up doing multiple consecutive calls that lead to cascading data calls here. So with GraphQL, I just can ask the server, give me the currently logged in user and its friends. But if we look at the query, we already see some repetitions here. And GraphQL has a concept that is called fragments. And with fragments, actually, I have a primitive for composition. And it allows us to create basically a hierarchy for fragments as we create hierarchies of components in our UIs. And that really closely aligns. And we see that later in the talk in my demo. Okay, so with GraphQL, we have actually just one endpoint because we, as the consumer of the API, we define what data we want to fetch. So we just need one endpoint to issue those requests to. And that also means that we can fetch everything, every data that we need in one specific moment in time with one request. And that removes the over or under fetching problem that we face with other API technologies. And GraphQL is built on a strong type system. And initially I said it's a query language for your API, and it is a runtime to enforce those or execute those queries. And GraphQL makes sure that you do no type violation. Like if you're exposing on your server side a field that that is a string, then it's guaranteed that it will never become int on the client side. And if you think about technologies like Swagger, where you define a schema or the schema is inferred from your type system, but you still could send in invalid data because there's no enforcement, no runtime that enforces a type system. And this is also useful because nullability of the type system, like if you're saying something will never be null, can be used on the client side because you can trust that the server will honor its contract. And that all makes GraphQL very predictable to use. So let's head into Blazor, or the actual subject that we want to explore with GraphQL. And I said initially with Blazor, Microsoft, for the first time in years, gives us a viable option to build real rich SPA applications that run natively in the browser. And what does it mean? So Microsoft actually built up a mono runtime, so basically a .NET runtime, and they built it up on top of WebAssembly. And WebAssembly is not a plugin technology, and it's no transpilation into something else like JavaScript. It's real .NET that runs in the browser. And that means we really can run .NET Core in the browser. And that also means that we can use all the code that we built up in .NET Core and .NET Standard, in all these .NET Standard versions, and just use it in our Blazor WebAssembly projects. And to us, that means we have to use less JavaScript, and we can almost do anything with .NET. And all of this runs at near native performance because it's not a plugin technology and it is not transpiled to, let's say, JavaScript or something like that. And as I said, WebAssembly is not a plugin technology. It's actually built into every modern browser. So it's a web standard, and it runs already everywhere. You can run it on your phone. You can run it on Safari, on Edge, and all the browsers that are up to date. Not Internet Explorer, by the way. Okay, so Blazor is open source like the rest of ASP.NET. And that really makes it super awesome because we can go to their repository, look how they build that stuff up. We can reason about their code and also provide issues or feature requests. I really encourage you to head over to their repository and engage. Okay, so how does Blazor work? Actually, in order to create Blazor UI components, we are using a combination of C# syntax, and we will see that in the demos I have, a combination of C# code and Razor syntax. And basically that compiles into a Blazor application. And the mono WebAssembly runtime will be downloaded with our Blazor application into the browser and enables us to run normal .NET assemblies right in our browser. And when you run a Blazor application in your browser and you look at the Developers Networks tab, then you see a lot of .NET DLLs that you think is very strange. And some people ask, is that safe? There's a DLL downloading into my browser. And yes, it is, because WebAssembly is actually run in a WebAssembly VM. So we have it sandboxed there. So there's no native access to your computer. And actually, these WebAssembly applications are not even allowed to update the DOM directly. There is talk about the standards group to enable that, but at the moment, a WebAssembly VM cannot update the DOM of the browser. So how that is done, basically, is that Blazor builds up a shadow domain, and the Blazor components really modify this shadow DOM. And then there is a JavaScript router. So you also see that there is a Blazor.js and there is a Mono.js. And basically, this JavaScript router will batch changes of the shadow domain very efficiently to our browser domain, browser DOM. And that works also the other way around, because all the changes on my browser DOM will be patched back to the shadow DOM, and then we get events raised in our .NET components and really can work just with .NET. So we actually don't see this JavaScript. Okay, so let's just quickly discuss the state of Blazor, because a commonly asked question is how mature is Blazor? So Blazor for the server side, and we are not talking about Blazor for the server side in this talk, Blazor for the server side is actually already out with .NET Core 3.0, so it's battle tested, it's out for over a year now, and it has proven at scale. And basically what they changed is they swapped out the way they update the browser DOM and introduced Blazor WebAssembly, and that shipped just in May, so it's very new. But so far I hadn't any issues, but it's very new. But Microsoft really wants to go further with that. So Microsoft wants to enable you to really take your knowledge that you acquired in the web with Blazor and put that on the browser. So there are previews upcoming with .NET 5 that put Blazor, that basically Blazor for progressive web applications and Electron. And then like with Slack, like Slack, for instance, is also an Electron app just. You can then build up applications with Blazor that are real desktop applications. But Microsoft is actually going further, and there are investigations or experiments with Blazor for native. And last year at NEC, actually Steve Sanderson showed off that you can swap out the renderer of Blazor and put in some other component technology. For instance, he took Flutter, which actually is written with Dart, so not even .NET. And basically, Blazor produced Flutter components. He called this, I think, Blutter. But there you can see what potential is there. And Microsoft is putting a lot of its eggs into the Blazor basket. So there's a lot more coming with Blazor. But I think that is enough for an introduction, because we want to build a real-time application that really takes Blazor to the next level. So I like a lot of code. So let's dive into some code. So when I thought about what could we build in a talk like that, and what is a real engaging real-time application, I immediately thought of something like Slack. Because if you think about it, Slack actually exposes different kinds of data fetching capabilities. Like initially when we open a channel or open a chat, we fetch data, simple fetch. And then we write messages. That is basically mutating the server state. And on top of that, we have real time, like the bubbles, for instance, when there are new messages coming in, or if I'm in a conversation, really the messages that are coming in. So Slack is really a good example of real-time application that really is engaging with the user. So I thought, let's build a Blazor clone. It won't be as beautiful as the actual Blazor, but let's try to build something up. Just smaller. Okay. So let me just open up my first demo, and we'll start with something simple. Let me just run that application. It's just a shell so far, and I walk you through how this application looks like. So we do .NET watch run, so we can change the code while we work on that, and it recompiles. Let me open Chrome, and then we'll just open it. Okay, and what we see here is basically a simple layout for Slack clone. So on the left-hand side, we channels or stuff like that. And at the moment, we just have dummies here. And then we have the main pane where we have all the message interaction. And that is what we build out later in the demo. So first, we want to fetch all the users that we basically can interact with. So we will fill out this pane. So let me walk you through the code a bit. So if we open up a Blazor application like that, we basically can see there is a program CS. And the program CS is very familiar to us because it's actually what we have in all these, all console applications. We have it in ASP.NET Core applications. So it's very familiar how what that is. And it even in Blazor has a main method. So that is nothing new to us. The next thing is we have a host builder here, and that's like in ASP.NET Core. We have some kind of a host builder that sets up all our environment. The difference here is that our builder has a root component, and this root component app, if we go in there, we can see that it's not C# code, it's Blazor code, and it hosts another component. And this main component is actually where the magic is happening. The main component has at the moment just a people list in there and some area where I can put code. And in Blazor, there's a concept of dumb and smart components, or smart and dumb components, or you could say also stateful components and stateless components. And main is our stateful component. So everything with state and will happen in our main Razor. Okay, so then we have our dumb components or stateless components, and we basically can see the people list here. And the people list now has some HTML here, so it's not just native Blazor tags. We can put just actual HTML in here, and we can see here are the placeholders. And if we have a look at the placeholders, they are just HTML. Last but not least, and that is the item we want to basically now bring to life, is the person item, and that represents an actual person in our list later. So let's have a look how we can bring that thing to life. So just as a side note, basically how that works with those components is that the smart components will push data down their component tree, and then if these stateless components will interact in Blazor, they will throw events, and the main components can react to those events. Okay, so let's bring that thing to life. So we want to fetch data with GraphQL here, right? So the first thing we need to do is adding a package. I did that already. It's the Strawberry Shake package. As I said, I'm one of the authors of the Hot Chocolate GraphQL library for .NET. The Hot Chocolate is actually the backend or the GraphQL server, and Strawberry Shake is the GraphQL client. Okay, so this is already set up, the project. The one thing I have to do now is to initialize my project to run a GraphQL client. And how I'm going to do that is basically in Visual Studio Code. So in Visual Studio for Windows, it's more guided through UI. I'm a Visual Studio Code developer, so we do more with consoles here. So I have a CLI tool here that is that comes with the package Strawberry Shake. And so I can do .NET GraphQL init. And then I have to add the GraphQL URL from my server. And I can give my client basically a name. I call it chat. So we have a chat client. I initialize it. Basically, what now happens is we are downloading chat GraphQL schema. And that's the schema from my server with all the types. And basically, the client compiles against this schema. We will see what that means in a bit. So the next thing I need to do is writing up queries. So I need another query file. So I'm adding a file queries here, .GraphQL. It actually can be named anything, and you can have multiples. So if you have various clients or various query files, that's not a problem. Okay, so the next thing we should do is head over to our GraphQL IDE, because our GraphQL IDE is much better to explore a GraphQL endpoint. And this GraphQL IDE is called Banana Cake Pop. It's also built by our open source project. Okay, so I prepared already here an empty pane. My server is set up, and I already specified a token here. So what I can do now is first have a look at my GraphQL endpoint. So let's explore the schema. So I can see there are a lot of queries here, and I can see there is the me query, and I showed you the initial example of my GraphQL server where I basically query on this me node. But I also have other things, like I want to really query for people, and I can see that my people endpoint is actually a paging API, and it exposes a person here. And I then can drill into the structure of my GraphQL server here before I even do the first fetch. And then I can see a person actually has a name, and I need a name, and also the last seen date. And to have this online status, I want the last seen date. Okay, so let's, I just closed my demo. Let's do that and write up some GraphQL. So initially, I actually showed you the shorthand syntax. We are using the longer syntax now. So I'm specifying I want to do a query here, and the query should fetch persons. Okay. And then I want to fetch from the people field. And actually, I saw there's a field nodes. I also have IntelliSense here, by the way. And from the nodes, I want to have the name, and I want to have the last seen. Okay, I can execute that. I get some data back. I can see, oh, it's actually not sorted like I wanted. So with Hot Chocolate, you have also these sorting APIs and these filtering APIs. It's not GraphQL in every GraphQL server, but some GraphQL servers have such capabilities. So now let's just order by name. And okay, that's exactly what I want. So I can grab this query and go with it over here, paste it into my query document, recompile it. And what actually now happens is that we really compile from the queries. So this query is actually compiled. Let me show you that. If I would like put a mistake in here, build that, then actually my the compile process of .NET would tell me that there is a field people that does not exist on query. And that's true. I can even jump here to my mistake and fix it. So it really compiles, and it compiles into C# code. So I now have here a person that actually has a name and the last seen. So actually what I specified in my query it now manifests as C# code. Okay. So let's build our client up. So let's go to components and start with the smallest component, and that person item. And I can see that my person item wants a username and a user last seen here. So I said we are pushing data in. So we need some way to push data in. So I'm adding a property here, and I'm annotating it with parameter, and that makes it a parameter and enables me to push data into that property. And now I'm just adding, like with Razor, always an add here, and this becomes actually now the reference to my property here, and takes from the user basically the name. Okay, so let's build that in. So person item is now done. Let's do the people list. And again, we need, this is a stateless component. We need some way to push data in. And in this component, I want to have an indicator that it's still loading, because if it's loading, I actually want to show these little placeholders so that we have no empty pane here. Just let me fix that. Okay. And then if it's not loading, and if there are data, I want to show something different. So let's add another property that really represents our data set of persons. So a person connection is basically my paging data. And then I can really add here an else. So if it's not loading and there are persons, then I will for each of the persons and add so many person items as there are persons. So that is quite simple. Okay, so we basically built up our list now. Let's head over to our main component and see how we really bring that to life. I said initially that we can use things like dependency injection. And in order to communicate with our server, we need a client. And we can now use a directive in Razor that is called add inject. And that basically pulls something out of our dependency injection. And now we'll just use the chat client that was generated, chat client. And then we have a way to communicate with our server. Okay, so we have to push data in here. So the way that works is over these parameters. And I actually have the people parameter here, and the is loading. So let's see, it's empty. So we now have to create some fields here so that we can bind our component to our component parameters to that field. So let's just add private bool. It's loading. It's loading here, and we are loading by default. So when the component initializes, we are loading. And the other thing was a person connection. And let's just add people here. It's a nullable component, and then we will bind the whole thing to people. And here we bind this thing to is loading. Sorry for my typing. Okay. So the next thing we need is to initialize our component, and there are lifetime functions in Blazor. So I can basically use this lifetime functions on initialize and say, let's initialize my component. And the first thing I would do is fetch data from my backend. So we have a result that is await chat client dot get person async, and that. There you can see that the operation from our GraphQL query actually became a function now on my client, or a method on my client, and I can call that. And then I basically said, ensure there are no errors on my results, so I know everything is okay. GraphQL actually supports partial results, but we are not dealing with them. And the last thing is we say the people actually is from our result, from the data. We know the data is not null because there is no error. And we want the people. And last but not least, we said the loading is now false. And in order to update my component tree, I now say state has changed. And with that, our thing should work. Let's head over to .NET. And OK, we see our client has already rebuilt. So let's refresh it. Oh, there's still an error. There's still an error because we haven't set up the dependency injection. Let's quickly do that. Go to our program CS, and the dependency injection is actually configured through our builder. And actually, it's already generated for us by our Strawberry Shake client. So I just have to say add chat client. And there is an important aspect about GraphQL, because GraphQL actually is transport agnostic. So we have to also define the transport. So add services, and we use an HTTP and HTTP client. And that is, again, an API that we use in the backend and that we just can use in Blazor now. So we say add HTTP client for the chat client. And actually, we want to configure the HTTP client here to use, let me just do that, base address. And then it's a new URI. And the URI is actually, I added that already as a snippet here. Move that. Okay. So we have the address, and then we, last but not least, have to add some headers. So we have a token, authorization equals new authorization here. It's a bearer token. Actually, I should have the token in here. Okay. Okay, so that should work out. We basically have set up our HTTP client factory here. It's restarting, it's compiling, it's up. Let's refresh that. Okay, our component is there. And okay, we have now our sidebar. It was quite easy and it was quite quick to build. It's a bit ugly, but we anti-uglify it in the next step. Okay, so would have left that open. Head over to our slides. So we did it. We built our first GraphQL integration into Blazor. It was not that difficult, actually. But let's head to the more challenging stuff. So what we built so far is basically the left-hand side. We built a simple people list that just fetches data. But we could have done that with other technologies as well as easy. But now let's build the more challenging stuff. So now we are building the middle area where we build message bubbles that flow in real time. And we build a footer where we send messages and interact. And after I have built this demo, there will be a link. I will post a link and you basically can send me messages into my debug session. So let's see how that works. Okay, we have 30 more minutes. I hope that we get it done by then. Okay, so the second demo is basically the full chat client that really works. So as the first demo, we now have already set up our our program CS to have the configuration for the HTTP client here. And we have our chat client generated. And actually, I changed the query here a bit to anti-uglify the left-hand sidebar. So we now tracking an online status here. We are tracking a profile picture here. And we also have the last scene. And I also already put some components in because building all those components on the fly would take too long. So we actually already have a lot of the stuff that we need in here. Like we have a message list now here that basically already has all the code in that we would need to build up. And we have our chat message bubble here and stuff like that. What we will concentrate on is really bringing these to life. And basically, we are building out the main component. And the main component is now set up as we left it. Basically, we have an initialize function that fetches the initial data here. So what we're going to build now is basically when we click on the person, we fetch the initial messages for that person that we are now communicating with. So when we click on the left sidebar, we're going to fetch some person. The next thing we need to build is when we click on the send button, then we really have to mutate the server state, so change some data and send the messages to our backend. Okay, and the last thing we then have to build in, and that is then the real-time stuff. So the messages flow in as we are sending in messages. So let's start. So first, let's grab the the, no, not the schema. Let's grab the query that we at the moment have in here. Let's go to our GraphQL IDE and let's put it in there. Let's just fire it up again. Okay, awesome. That works. We just get some persons here. So the next thing is really that we build up fetching the messages of a person that we are chatting with. And we are going to do that. Let me fix one. Okay, the way we're going to do that is, let's have a look at our schema. We basically know the email address of the person we are communicating with. So we are getting a person by its email. And then we can see here's a message connection. Again, the paging API or the relay paging API that allows us to go through our messages. And we basically then can fetch the message. So we have a direction here, basically is an incoming or outgoing message. We have a recipient that is a person, a sender that is a person, the send date, and the text. So let's try to build from that knowledge query. So we go back in here and we call this query get messages. Okay. And then we basically would look up a person by email. And this field in GraphQL actually has an argument. So that means I have to pass something in here to get the person by email. And GraphQL actually has the concept of variables where I can define, okay, there's a variable email. And this variable email is a string. And this means it's not nullable. So you cannot put null into that operation. And then I can assign to my argument here the email variable. And this basically translates into a method on C# that then has an argument email where I can put in my data. So I'm really creating here my interface for my client. Okay, let's do the next thing. The next thing is we need the messages that I have with that person. And from that messages, I need the ID, I need the direction, I need the recipient, and that is a person we saw, so it's an object. And we need a sender, again an object, and it's also a person. And then we need send date and the text. So we pretty much need everything in that case. So actually we would need the name, the email and the online status for these participants. But then again, I introduced the concept of fragments that makes it much more understandable how our data graph works, and also drives how we create components for a C# client. So let's build a fragment that is called participant. And this fragment we apply on a person. And then we grab these fields here. And actually, instead of the fields up here, we now use our fragment participant here. So, and now we really can change our whole graph actually, because we are using the same fields here. So every person is actually also, it could be also a participant. And if we look at that, actually, we could take that out. Right, okay, that is our person. And then we create our own shape for our client that is called person. And that is now how a person is represented in our C# client later. And I'll walk you through that in a bit, how that generates really. And last but not least, we have a thing that we should call a message. And that is now our message fragment, our reusable component here. And we put that in. Format that. And now we are just using components in our functions and in our operations. And that really makes a difference. We will see when we can generate that. But let's first put the last piece in, and that's a mutation. So we want to mutate the server state, and it's called a mutation in GraphQL. So we say send message. And then again, we want an email here because this is basically the email to which we send, or the user to which we send our message. And then we put in a text. That's a text that we actually want to send. And it's also a string that cannot be null. Awesome. Okay. And there are quite a lot of mutations here. I could invite friends, but we are picking the send message mutation and providing an input here. And we provide the recipient email. It's called email. And actually, we provide the text for the message. If you're wondering why there are no commas in GraphQL, they're actually not necessary, because the first thing the compilers of JSON or stuff do is throwing the commas away. So the designers of GraphQL just decided you can put commas in there, but you don't have to. Okay, so a mutation always returns the changed state of the server. So what you change on the server will be returned. In that case, we are returning the message, the created object. We're also returning the recipient and the sender, because their state also has changed, because their messages property also has a new message now in there. For our use case, we just need the message that is produced, because we want the message with all its IDs. And then we just say, okay, that's actually also a message in the way we want it. Okay, let's grab that, put it over here, and let's compile our thing. Wait, did I actually do that? Okay, so we're compiling that, and what it actually did is it now updated our client, and we now can see that we have actually a person, and this person now is also a participant. So actually, what we generated from the components is actually the real C# clients with all the inheritance and stuff like that. So you really are in control how your client is shaped, and that, as I said, that puts the front-end developer in the driver's seat of how to fetch data and stuff like that. Okay, so we go in the main back, and what we're going to do is now we basically put in our message list here, and the message list actually gets, again, a loading signal. So if it's loading and shows something different, then we are putting a recipient in, and that's the selected recipient, and we have to build that. And then we, last but not least, we are providing also messages, the messages that we have with that person. So the first thing we are going to do is let's add another field here that is called person, which is a person, the recipient. And then we have the second field that we need, and that is an immutable list, which is an immutable list of messages, and we call it messages. And in the beginning, it's just immutable list messages empty. So it's just an empty list, because at the beginning, nothing is selected, so it should be empty. Okay. And now let's really build up our function. So when we click on a person, the first thing we basically get provided the component really senses down the person on which the user clicked. So I get an object here, and I really could then just grab our client code here, so I don't have to type so much, and change it and say, okay, actually, we are going to fetch the messages now. So you see the client really generated these new operations in. And I can then just grab my person that is already in my component tree here, and just pass in the email. Okay, I ensure that there are, again, no errors. And then I really set my fields here. I said the person is now the recipient, and actually the messages is now an immutable list, and create range. And we actually take from the result, again, we know that data is not null because we have no errors. So we take from the person by email operation, we take the messages, and from that the nodes. And this is not null when there is no error. And last but not least, we just inform our API that we have, our UI that we have changed the state and the comments shall be updated. Before we start that, let's just put in the last piece, and that is sending the message. And that is also quite simple. So when on the message list, basically, a click send is raised, and this message here is raised. And basically, we can just grab the code that we have here and then modify it again, because instead of getting the messages, we are sending a message. And instead of person, we are using now our recipient property. And we say, okay, we know it's not null when this is raised. I will answer to the questions once we are through that demo. Okay, and then we just provide the message that our event sends in here. So the component gives me the message that is really produced here. And then we really send that to our server and ensure again and that there are no errors. Then we update just our messages. Add, and we now grab from the result, because I said we are reselecting the change state of the server. So we are just grabbing the message here, and state has changed. So we are updating the server state. So this should actually run. Let's try it out. It's always a surprise when it doesn't. Watch run, because we are going to change it. There's no real time yet in, and that's the last piece we are putting in. So let's start that. Okay, it's up. Let's just call our client. So we can see now we have the left-hand side pane, which actually is now a bit more anti-uglified. We can now click on it. And now we can see that the server that we fetched actually the messages from my server. I can see, by the way, that we did a mistake here. It's not ordered. So we add an order in a minute. But OK, we have the messages in here. And I can also send something. Send something. We send it. And we have a message here. So we can see that that all works. Let's get some real-time data in there. Let's head back to our GraphQL IDE and build it up. So actually, I said we did a mistake here, because it's not the messages are not ordered correctly. So let's put some order in here and say we are ordering it by the send date, ascending. Ascending. Okay, so that fixed our error with the message sorting. We will see that when we put that back in. And last but not least, let's put in real-time data. And real-time data is really in GraphQL is the same thing than a query, or at least from writing that up. We basically say, okay, we have subscription, and subscription are real-time operations. And the operation here, we call it receive messages. We could also call it on receive messages or something that we want. And then we can have a look at what operations or fields do we have here. We have one field, and one field in this case is an event. We have an on message received here. And if we hover over that, we can see that this is a message. So we are getting messages as we receive them on the server. It's pushing them down to us. So we can now use our data shape again, our fragment here, and say, okay, that's a message. But actually, in this case, I really want to rename the field for my client side and call it message. And that's just an alias. So you can also rename the fields that the server tells you. So it's nicer with your API on the client side. Okay, let's grab that and really just copy it back to our code. This one. Okay. Okay, it's already rebuilding. And let's get back into our main component. Reload that. And put in the real-time data. So how that works is, and I'm just adding that from a snippet here and explain it because it is a bit of more code. So really, I have a different name here. Just let me fix that up and then I explain it. Okay, so messages, actually real-time data is represented in our C# client as something called a response stream. And a response stream is actually an async enumerable. So what I can do is I can tell my client I want to receive the messages, and then I get back an async enumerable or response stream, and then I can await for each, asyncly for each over that, as long as it works. And each result I can check, is there an error in that result, or and is the recipient, by the way, set here, then add that to my message list. Okay, so and I really run that in a task just with task run. So multitasking is also quite simple with Blazor, because I just can task run like on the server. Really, it's .NET Core here. It's nothing special like with Silverlight. And then I'm just, in this case, I could do it more sophisticated, but just for the demo, where we just begin receive messages in our initialize function that will basically open up the connection to the server and receive messages as long as we are iterating through that. But we are not done that, because real-time data actually doesn't work over HTTP. We need another transport layer here. And in this case, we are using actually WebSockets. And we did a lot of work to abstract that. And actually, the API now works as the same like the HTTP factory. You can put middlewares in. It's just saying add WebSocket client here. Then you specify the client. And you actually just specify the UI you want to connect to. In this case, I'm using a token of as an argument to my UI, but I wouldn't do that in real life. I would use message-based authentication here and put really the authorization token on the message. And there are also other stuff that you have to take care of in a real life example. But okay, for now, we put in basically just, we said add WebSocket client here, specified our UI, and the thing should have recompiled and should work now. Let's refresh that. Let's see if that works. Yeah, that works out better. I have a message here. I could write something foo. And now really, let me just head over back to my slides. Now we can test that. You can grab this URL, and then you can really send me messages in. So try to grab that over here. I do that too. Let's do another window. Put that in. So chat audience at azurewebsites.net. We can say hello. Oh, there's already someone writing in messages. You can see how they are coming in. Awesome. You can see how easy it was with GraphQL to build real-time applications here. And you still have to do some heavy lifting, like you have to scale your server correctly and stuff like that. But just to get you into GraphQL and Blazor, you can now really build real-time applications, rich SPA applications in the browser. Okay, so awesome. It works. It load tests. So let's move on and to our conclusion. Testing NDC. Okay, so we did it. I never did this talk actually in 60 minutes, and usually I take 1.5 hours, because then I would really walk you through deeper to these through these examples. It's the first time I actually reached under 50 minutes. There's another conference where I have to do this in 30 minutes in August. So we'll see how that pans out. Okay, so my conclusion about these two technologies here is really you can iterate much faster with Blazor and GraphQL together, because firstly, I'm actually a backend developer. I'm used to C#. I'm not good at JavaScript. And Blazor actually enables me to use all my knowledge that I acquired and use all my APIs that I used for years and really run that in the browser. And soon really run that as an Electron app and really create awesome desktop applications with that. So you can reuse a lot of code and reuse a lot of knowledge that you acquired as a C# developer. And really with GraphQL, you can fetch data so much more efficiently. And it's not just some untyped data. GraphQL is really strongly typed and awesome to set up. And it really enables you as a consumer of the API. Strawberry Shake actually is at the moment preview. We targeted actually to release it in May. It's a public preview, so you can chime in there. We are now targeting end of July and hope to get it done by then. Also, the tooling that you saw here, we have our project also built this GraphQL IDE called Banana Cake Pop. And we are also building at the moment integration into Visual Studio, so you just can click and add a GraphQL client to your solution without any console tools. And really, we bring in nice syntax highlighting and IntelliSense to Visual Studio. Basically, what you saw in Banana Cake Pop will be integrated into Visual Studio. We are not stopping there because I said GraphQL is really transport agnostic. So we are also working on the server and client side to provide it over gRPC, so you can have much smaller payloads than with JSON payloads. Okay, so if you want to head to our project, it's basically go to chillicream.com or to our GitHub repository. It's all open source, and I hope you enjoyed the talk. And now I'm heading to the questions that, let me just see where they are. Okay. Let's start at wish I could have a whole room for Lego. Yes, that is actually it was my son's room. I made it into an office and it was his Lego room. I'm sorry to him, so I have to kick out my kids all the time. And there's still messages coming in. This is so simple. Wow, the hot chocolate and strawberry APIs are so easily used. Yeah, and that is one of our main design goals, to make GraphQL really simple to .NET developers. Would be nice if there is some magic to autocall. State has changed. Yes, but I imagine that is quite challenging also. But I mean, it's easy, and you can control really when you want to update the component tree. You can also unmute yourself and ask questions in person, by the way. Oh, yeah. So there is a question about authorization with GraphQL, and that is really baked into Hot Chocolate, the server side. So basically, you can put authorized directives on your fields and then specify a policy. And we are basically using the policy API from ASP.NET Core. So then we basically apply these policies on your data. And we are doing much more there with version 11. We are planning to bring in a new API that also does data trimming. So basically that we use policies to get data out of the results. There's no script support. So what's the name of the tool? So the GraphQL IDE is Banana Cake Pop. You get it, head over to our homepage, basically, or our repository, and then you can grab the GraphQL IDE there. We are developing actually a ton of tools. Yeah, there it is. Banana Cake Pop. Names are epic. Yeah, we thought simple names like GraphQL.net is boring, or NGraphQL. So we really love how the JavaScript community is naming the components. So we started naming them actually like cakes or drinks. Could you briefly how query resolvers work in the server? Oh, that's a real whole conference talk I have about that. It's there are so many ways you can do resolvers in the backend. And really with Hot Chocolate, you can also just do schema stitching. So the Hot Chocolate server has really rich capabilities to merge in data and stitch data together from various data sources. Just head over to our Slack channel. It's posted on our repository, and then you can just talk to us. We have a really active Slack channel. In GraphQL server, also providing the WebSocket server. Yes, so basically we have built a middleware for GraphQL, and all these communication protocols are natively supported by us. So you don't have to code anything. You just say use GraphQL or use GraphQL WebSockets and stuff like that, and then it's really in your server. And on the client side, you saw these add WebSockets that's really generated from us for you. So all the state handling, we do a connection pooling, and you can really put in middlewares on top of that, and we really do that for you. Any more questions?